All right, the last conic section that we're going to talk about are hyperbolas. So hyperbolas have two U-shapes. So as we look at this complicated picture, we're going to talk about the different parts. And once we understand those better, this will be a lot less intimidating. So the actual hyperbola itself are the U's. So in this picture, I have these two U's opening sideways. So they can open sideways or they can be vertical where they're opening up and down. But with a hyperbola, we will always have the two U shapes. And similar to the parabolas and ellipses, we're going to have those axes of symmetry, but we're going to call them different names. And the reason for that is we don't want to confuse them with the other two terms because they're similar, but they're not the same. So just like with parabolas, we're going to have a vertex on each U. So here are the two vertices. The distance between our two vertices is still going to be a distance of 2a, just like with the ellipses. Now, instead of this being called the major axis, on a hyperbola, we call this the transverse axis. And the reason for that is because this is no longer necessarily the longest piece on our graph. We could have this axis be longer, where the co-vertices are connected. Okay. And for the co-vertices, we're using our b value. So from this co-vertex to the co-vertex, it's still a distance of 2b, but now we are calling this the conjugate axis, meaning the opposite of the transverse axis. So it is possible for this axis to be longer than the ones connecting the vertices, which is not true in our ellipses. So that's why they have different names. And keep in mind, everything that is dotted is not actually a part of our graph. We're just using those pieces to help make it easier to graph. Okay. We also have the focus points. So just like with our parabolas, the focus points are going to be inside of our U-shapes. And the distance between the two focus points is still a distance of 2c. And we still don't have a specific name for that. We just need to know that distance is the same from the focus to the center here. And the center is still going to be h and k, just like it has been on all of our previous conic sections. Okay. Now, when we start graphing these, instead of having to figure out all of these individual points or multiple individual points, we're going to use what are called the asymptotes. So this dotted line right here is called an asymptote, meaning our U shape is going to get really close to this line, but it's never going to touch or cross over it. And same thing with this one. This is the second asymptote. So on the other side of our U shape, it's going to get really close to this dotted line, but it's never going to touch or cross over it. Okay. So when we graph, we always start with our center. Whatever the direction of our hyperbola is, we're going to go that direction, our a value. So if it's horizontal, we're going to the left and right. Then we go the opposite direction for the b value. We're actually going to connect this into a box, and then that box is going to give us the slope of those asymptotes. So then we would graph those next. And then when we make our U shape, it has to go through the vertex point. And then as we make this, it's going to get really close to these asymptotes, but never touch or cross over them. And we'll go through an actual example like that as well. Okay. So next, let's look at our formulas. So these are going to be similar things to our ellipses, since our vertices are still dealing with A, co-vertices are dealing with B, and the foci are dealing with C. Center is still H and K. So what's important to remember is the standard form equation is going to look different. So notice how instead of an addition sign, we have a minus. So that's how we tell whether we are dealing with a hyperbola or an ellipse from the equation. Now, if you remember, in the ellipse, the x minus h and y minus k were always in the same position, and then we determined the direction by where the larger number was. So if our larger number was under our x for an ellipse, then that meant it was horizontal. That is no longer the case for hyperbolas. So for hyperbolas, our fixed positions are now our a and b. So in our equation, the a squared will always be underneath the positive term, the b squared will always be underneath the negative term. So whichever term is positive, that determines our direction. So if my x squared group is positive, that tells me that it's horizontal and the u's are going to open to the left and to the right. And if our y squared term is positive, that tells me that it's going to be vertical, so our u's will open up and down. But again, a is always going to be underneath our positive squared term, b is always underneath the negative squared term this time. So it's important to remember those subtle differences. And again, if you forget, all of this information is on that gold formula sheet that we've been using. Okay. And then at the bottom here, we have the equations for the asymptotes. Now, when we graph them, we're going to focus on making this box and then just connecting the corners of it. But when we write the equations, this is the formula that we are going to use. Now, notice that it's still y minus k and then that x plus h in there. So what's changing is the slope, depending on which way we are graphing our a and b. So again, when we are graphing, it's important that we're paying attention to those little details. And if this fraction can be simplified, then we do want to simplify that. And when you do this topic in ALEKS, it is going to tell you that it has to be in the form of y equals, where we don't have those parentheses. So you are going to have to simplify this and write out two separate equations for your ALEKS topics. Now on your paper, I don't care about that part, so you can leave it in this format on your paper, or you can follow the same rules that you're doing for your ALEKS topics. Okay, but in ALEKS, you do need to solve these equations for y and simplify by getting rid of those parentheses. And I will post a video showing you that in the video lessons.